11.3 Systems of Nonlinear Equations and Inequalities. So the last section was solving matrices and kind of building those, and that those are likely not going to be on the final. This, at least what I'm going to cover right about now, will very likely be on the final, and that's kind of the same thing as the next section. We're going to do circles, and that will very likely be on the final. But these are both going to be very abbreviated. So again, I don't think I'll make the homework assignments be due in their entirety. Maybe I'll make some of them optional. Maybe I'll make all of them optional. Just make sure that you're kind of checking your emails and saying, okay, well, maybe this is a homework replace versus actually what I'm required to do, and then you might panic and say, you've never learned how to do this thing. Okay, so parabolas. When we talk about systems of nonlinear equations, we're going to have maybe one equation will be linear, which means it'll be a line, and maybe the other equation will be a parabola or a circle or an ellipse, if you know what that is. And that's kind of the idea of this section, is to say, okay, we don't have to necessarily have equations always be lines and then just assume we're going to be able to solve that system, or that we're not. So when we're dealing with a parabola, if we have a parabola, one of them that's a nonlinear equation, and we have a line, which is obviously a linear equation, what kind of solutions can we have? And what these three graphs kind of show us is that if we have one line, if I have one parabola, I'm only going to have three possibilities. I'm either going to have no solution, which means the two equations just aren't going to intersect ever. I'll have one solution, which means my line and my parabola will touch at one spot, or I could have two solutions. My graph is going to, or my line is going to intersect my parabola twice, which is a little bit different from lines, because lines you're only going to have at most one solution. And it also tells us that I'm never going to have to search for more than two solutions. So if I have my two solutions and I've done my work correctly, I'm not going to have to say, okay, well, maybe there's a place where the line intersects my parabola at a third spot. So really, these are the only three possible options, which is actually very similar to when we were solving just straight up quadratic equations, if you remember that, because really the quadratic equations we're solving for when a parabola will intersect the x-axis, which is itself a line. Okay, so that's all verbal. Really what you need to be capable of doing in this section is solving a system of equations that is not linear. So here we go. The first equation that I have right here is in fact a line. If you solve for y, you would be able to plot the y-intercept and graph it. The second one is not. And once you have x squared or x cubed or x or y to any power that is not just one, then you start to have a nonlinear system of equations. And so to solve it, typically there's kind of two ways to solve system of equations in general. We usually talked about kind of elimination method or substitution. This section we're going to heavily favor substitution, but elimination kind of has its merits. It's just harder to use when we're dealing with squares and cubes and stuff like that. So if those terms don't mean anything to you, that's perfectly fine. What we do with substitution is we say, okay, I'm going to try and solve for one of my variables. Because if I'm able to solve for one of my variables, then I can kind of condense it into a single equation versus having two equations with two variables. And then I should be able to solve. So that's exactly what we're doing here. I moved the 2 over, I added the y to the other side, and now I have solved one of my equations for y. And then what I'm able to do with substitution is I say, okay, I know y is equal to 3x plus 2. Now I can take that and plug it into my second equation. If you plug it into your first equation, you're just going to get 0 is equal to 0, which isn't super helpful. So I plug it into my second equation. And my second equation is 2x squared minus y is equal to 0. So I replace my y with 3x plus 2. Notice that the parentheses are there. That's important. That's been a theme in this course. If you don't do that, you're probably not going to distribute your negatives correctly, and you might not get the right answer. Well, you won't get the right answer. So then I distribute my negative to both terms, and then this looks kind of like a factor by grouping problem, or maybe if you're really good with a quadratic formula, you can use the quadratic formula. I like factor by grouping, so let's see if factor by grouping works. So I multiply my first term by my last term, I get negative 4. My middle term is negative 3, I put that on the bottom of my x, and now I kind of play that factoring game of I want to find two things that multiply to get me negative 4, add to get me negative 3. Well, those two things are negative 4 and 1. So now I break up my equation, so I copy over the 2x squared, I'm not going to change that at all. I break up my negative 3x into be negative 4x plus x. Those are the two sides of my kind of big X in the factor by grouping. And then I bring over my negative 2. I don't change that. And now I group it. So I write my first two terms in a group and my second two terms in the group. I look for my greatest common factor in the first two terms. I get 2x. If I pull out a 2x, I have x minus 2 left behind. And the second one, I actually don't have to do anything because my x minus 2 already matches up. So I just pull out a 1 kind of as a placeholder. And then my factor by grouping becomes, or my two factors become the things in front of my parentheses. So 2x plus 1, that's one of my factors. And then the two repeating factors. So it's going to be 2x plus 1 times x minus 2 is equal to 0. Now I set both parts equal to 0 and solve. So if I solve 2x plus 1, I would subtract 1 from both sides, divide both sides by 2, I get x is equal to negative 1/2. And in the second equation, I just add 2 to both sides, so I get x is equal to 2. Now, when we're solving a system of equations, what we have to do is once we solve for one variable, whether it be x or y, in this case we solve for y, I have to go back and find or in this case we solve for x. Yeah, we solve for x. I have to go back and solve for my other variable, because if I'm solving a system of equations, I have to have solutions for both my x and my y. So I believe I started with, okay, I plugged in negative 1/2 into the second equation. I could have done the first equation. Honestly, I don't know why I picked the second one. It seems like it's harder, but that's fine. So I plugged in my negative 1/2 into the second equation. I'm going to square my negative 1/2. Negative 1/2 squared gets me 1/4. 1/4 times 2 gets me 1/2, so I kind of did two steps in one right there. Then I add y to both sides. Y is equal to 1/2. So that's one of my solutions. I'm going to write that as a point. My x value that I plugged in was negative 1/2. I got an answer of y is equal to 1/2. So my solution is negative 1/2 comma 1/2. And now I do the exact same thing for the value 2. I'm going to plug 2 into my second equation. Could have done the first equation. I square 2. 2 squared is 4 times 2 is 8. I'm going to add y over just like I did before. Y is equal to 8. And so then I'm going to write this next guy as a point as well. I know my x value is 2. I know my y value is 8. So my point is 2 comma, it should be 2 comma 8, not 2 comma 2. Let me fix that. There we go. 2 comma 8. Now, moving into circles. So circles is another nonlinear function that we like to talk about. We will talk about it more next lecture. But same type of process, that if I have a circle and I have a line, I really only have 3 types of possible solutions. I can either have no solution, I can have one solution, I can have 2 solutions. And this is, again, this is kind of surface level what we will be concerned about for the final, but that doesn't mean that anytime you have a system of nonlinear equations, these are the only possibilities. If I combine a circle and a parabola, I can have more than 2. I could have 3. I believe I could have 4 as well. I'd have to sketch that to be certain. But I certainly could have 3. So don't kind of get in this mindset of when you see nonlinear, your only possibilities are no, 1 or 2. Really, it's a good idea to kind of draw a sketch, like draw a circle and then say, oh, is my second equation a line? Great, then these are the only possibilities. Is my second equation a parabola? Well, let's see. Could I make it so that I could draw a parabola that intersects my circle at more than 1 spot, or 2 spots, or 3 spots, or 0 spots? So that's kind of the idea of these first slides is, yeah, I'm not going to really ask you to sketch something out on the exam, but just know that there is these possibilities. It's going to either be no solution, 1 solution, 2 solutions, when you know what types of equations you have, so that you can kind of maybe check your thought process at the end of the day. So now we're going to get into solving a system of equations that have circles. And so my second equation is a line. I could kind of manipulate that a little bit and solve for y and be able to draw a sketch with an intercept and a slope. First equation, we haven't seen it before, we will see it shortly, is a circle. So if I were to graph that equation, I would get a circle. So we know again that I could either have 1 solution, I could have no solutions, I could have 2 solutions. So we should be aware of that when we're going through the problem solving process. Now, again, there is the elimination method. This is a really good example where elimination is going to give you a bit of a headache because if you know anything about elimination, you would have to multiply through by maybe x, and then you're going to, once you cancel, you have y squared xy or something. So this is a really good, another good example of we should just use substitution, what we saw before. And the previous example, it was really easy. Well, it was easier to solve for y than for x. In this case, it's easier to solve for x. So I'm going to solve for x by adding 3y to both sides. And then once I have this, again, I'm going to plug this into the first equation now. And I'm going to simplify. So 3y minus 10 squared. Once I FOIL that out, I'll have 9y squared minus 60y plus 100. Plus y squared is equal to 10. I simplify further, combine like terms, get 10y squared is equal to 60y minus 60y plus, and then I just subtracted my 10 over as well, plus 90. So now I have something that looks like maybe I could use factor by grouping, which you could, and maybe I can use quadratic formula, which you could. Again, you're going to get kind of really big, nasty numbers. Or we can see that each of those terms has a 10 in it, and so if I divide everything by 10, I'm left with something that's pretty easy to factor. So that's exactly what I'm going to do. I'm going to divide everything by 10, and then if I factor out that middle thing, well, okay, I want two things that multiply to get me negative, or multiply to get me 9, add to get me negative 6. Well, it's negative 3 and negative 3. And so I'm going to factor to y minus 3 times y minus 3, which is just y minus 3 squared, which is just y minus 3 is equal to 0. Add 3 to both sides, I get y is equal to 3. Now I take that, I plug it into, in this case, the second equation looks a lot easier, so let's use the second equation. I'm going to plug in 3 for my y. I would add 9 to both sides and get x is equal to negative 1. Oh, I ended a little bit early. And so if I were to write this as a point, which I should have, I would write it as negative 1 comma 3. Now you might be thinking, oh, wait a second, you said that we would have two solutions. And the last example had two solutions. Well, again, there's possibilities. So you could have 0 solutions. I could have solved and gotten something that had no solution. I could have gotten 2 solutions. That's a possibility. In this case, it is possible to draw a line through a circle that only intersects at one point. So even though I have one answer, the point negative 1, 3, that's perfectly fine. I did my process correctly. If you got an imaginary number, like if I plugged in 3 into my first equation, one of my solutions would be an imaginary number. I count that as an extraneous solution because in this section we're assuming we're talking about when graphs intersect, and we can't really have a graph, or at least what we've seen in this course, we can't really have a graph that has an imaginary number being plotted and other real numbers being plotted as well. So if that happens, say that's part of my no solution, and maybe something else would work, and in this case, negative 1, 3 is the correct solution. That's the end of the section.